So we're going to talk about the change in position. If you look at the change in position, middle of page 50, there is a reflection, rotation, and translation. So we have reflection, rotation, and we're going to have translation. Okay. So these are the two things that we're gonna focus on today. Mainly gonna focus on this guy here, translation. Okay. Reflection is when you reflect a shape across a line. Okay. So if you look at the thing in the middle of page, you can see that a reflection is a transformation across a line called the line of reflection. Each point and its image are the same distance from the line of reflection. So in other words, if I had a triangle look like this and I'm going to reflect this across this, okay, it's going to, the new shape or the new thing is going to look like this, because I took this and I reflected over this way. What they mean about the distance are going to be the same is that this distance from here to the line and from here to the line are the same. And also this distance here from the line of reflection to the line from here are the same, because these are the points. This is the point that was reflected across to be this point over here. And this distance and this distance are going to be the same as what they're saying there. Okay, so that's what they mean by being the same distance. Okay, that's reflection. Rotation is where you take one and you actually use a point and you rotate it across. Okay, from that point. Okay, and that's kind of shown there in the middle. Rotation is a transformation about a point P called the center of rotation. Each point and its image are the same distance from P. Okay, so that's how you would do that. So that's rotation, and translation is really taking a shape and you're just moving it across like this, or from here you're moving it this way, or moving it down, or so the shape doesn't change, you're sliding it across. Okay, you're not picking it up and rotating it, or reflecting it. You're not moving it across in a rotation, but you're taking it and just moving it like this, moving it anywhere you want. Okay. Translation is a transformation in which all points of a figure move the same distance in the same direction. Okay. Example number 1, identify the transformation, then use arrow notation to describe the transformation. Okay, so let's go and see if we can do that. So we have a shape that looks like this, and our new shape looks like this. Okay, and we have EFG, EFG. So we have a triangle EFG, and we have a new triangle E prime, G prime, and F prime. Okay, all right. So as you can see, since E and E prime are over here, G and G prime over here, F and F prime are over here, okay, this is definitely not a translation, correct? We know that it's not a translation. So the question is whether it's a rotation or a reflection, right? So if this was a rotation, I would have taken this and I would have rotated this around like that, where E, which is over here, would actually end up over here. And F prime would end up over here. Can you see that? If I rotate it across, it would rotate like this. Okay? So obviously it's not a rotation either. Okay? And actually what it is, it's a reflection. So I pick this up and I moved it, I put it over here like that. So the line of reflection is probably going to look like that, where this are the same, and this guy are the same, and this guy and this guy, the length are the same. Do you want to see that? So that would be a reflection. Okay. Let's move to the next one. Within example number 1, there's a B there. Look at the B, we have a rectangle that was initially like this. UTRS. And it's going to end up looking like this, where I have U prime, R prime, T prime, S prime. Okay? Again, this is not a translation, because if it was a translation, it would have went like this, right? It would be like this, and I would just move this somewhere, anywhere over here, right? And I'm never going to be able to do this. So it's not a translation. Question is it a rotation or a reflection? Okay. So if it was a reflection, I would be able to draw a line right here. Okay. I would draw a line here if it was a reflection. And this guy over here and this guy over here would be the same. Well, it's not, because this is U prime, this is R prime and U. They're not matching up. Okay. So it's not a reflection, which means actually it is a rotation. By process of elimination, all we have left is rotation. And if you look at it, it makes sense. I go from here and I rotate across like that. And the U that was here goes to U prime, R that was here goes to R prime. Again, the T becomes T prime, S becomes S prime. Okay? So that's how that works. Okay, let's go to example number 2. Okay, example number 2, drawing and identifying transformation. The figure has a vertices -1, 4, -1, 1, and 3, 1. After transformation, okay. And okay, so draw the initial image and then the pre-image and then the image. Okay, the pre-image is the image before you do any type of transformation. Okay, the image at the end is after you did the transformation. So I'm not going to draw this on the board, but if you look at example number 2, look at your book, you can see clearly that it is a reflection, right? You're actually reflecting it across what? Can anyone tell me what the line of reflection there is?
The x-axis.
The x-axis, right? So you were taking the triangle that was here and you're moving it, reflecting it across to the x-axis, correct? Okay, so example number 3. If you look at example number 3, translations in the coordinate plane. Okay, so we are actually going to do a translation now. We're actually going to tell us it's a translation, okay? And we are at -4, 0. And then we are at -1, 1. -1, 1. -3 and 3. Okay. The translation they want us to make is x plus 3 and y minus 4. So you're going to take the points, okay, and you're going to apply this translation, which means that, okay, the points are given as A, B, C. So this is A, B, C. So let's look at A prime first. Let's do the translation to point A, just point A. So we're going to take whatever have we X, and we're going to add 3. Okay, and then wherever we have Y, we're going to subtract 4, which means Y-wise, we're going to go up or down. If I'm subtracting 4, I'm going to go down, right? Correct? I'm going to go down. Okay. So for A prime is going to be -1 plus 3, 1 minus 4, which is -1 plus 3 is 2, 1 minus 4 is 3. So I'm going to get 2 minus 3. So this guy here is going to be my A prime. Okay. My B prime is -3. My B is -3 and 3. So my B prime is going to be what? I'm going to go -3 plus 3. And then I started with 3 minus 4. So B prime is 0, -1. So 0, -1. So that right there would be my B prime. Let's do C prime over here. Initial C prime is -4 and 0, right? So -4. The transformation I'm going to make is +3. So +3. Then I had Y is equal to 0, and I'm going to subtract the 4. So C prime is -1, -4. So -1, -4. It's going to be down here, down here. Okay, so it's going to look like that. So I took this guy and I moved it down here. Okay, wait, something's wrong here. No, it's 0, -1. So it's 0 and -1, which is actually right here, correct? It's right here. So this is B prime. This is C prime. Go like that. So basically, I took this guy and I just slid it right down like this. If you look at it, it makes sense because I am going from here, I'm moving it +3 this way because I'm going +3 in the X, +3 in the X, and going down 4. Okay, so that kind of makes sense there. Okay. Okay, so that's that. Okay, last but not least, let's see if we can do example number 4. Okay, example number 4, we have the pattern shown is a similar pattern on the wall of Alhambra. Write a rule for the translation of square 1 to square 2. Square 1 to square 2. So we start with square 1, and then we go to square 2. So we have square 1, which is here with little points. This is square 1, and I'm moving to square 2, which is up here. Okay. So actually there are several different ways I can go from here to here. I can rotate across, or I can reflect it across here, except it gives you that this point here is A, and this point here is A prime. So it gives you the A and A prime right here. Okay. So now that I have this, I see that I can't reflect across and get that. Okay, because if I reflect it across, where would A prime be? If I reflect it across, A prime should be right here if I reflected it across a line here, right? So it's not a reflection, obviously, right? So it's not a reflection, which means that now it's either going to be a rotation or a translation. Okay. So is it a rotation? Can I rotate across and get there? The answer is no, because if I rotate it across, A prime would be over here. Okay, so I can't rotate it, which means that it has to be a translation. So I went here, I moved it up, and I moved it to the left. The question is, how many of each did I go? So it looks like I start from the point, so A looks like it's going to be 3 and 1 over here. So here is 3 and 1. A prime looks like it's going to be 1 and 3. Okay, so what happened? So in the X direction, I went that way too. So in the X direction, I'm going to the left 2. In the Y direction, I'm actually going up 2. So that's the translation. Okay, so the X direction, I went -2. I went that way 2. Y direction, I went up 2. So I went up 2. And that looks good. All right. Any questions on 1.7 you want to talk about? Any questions? Okay.